So here we are proposing blockchain-enabled continuous auditing framework. So the investment and attention in blockchain technology and embedded smart contract has tremendously increased in accounting and other professions due to its characteristic, which is immutable, decentralized, and transparent. Those features can potentially ensure the reliability of audit evidence and improve transaction auditability and are receiving increasing attention. So the reliability and secure data are desirable when running an accounting information system, since when audit evidence reliability is not appropriately considered, audit efficiency and effectiveness can be compromised. Also, auditors will spend less time in verifying the accuracy of the data, so which will save effort and time. And then we think that one new way of meeting this industry needs can be found in blockchain. However, even though the optimistic expectations of blockchain technology adoption, there's minor contributions, or the blockchain technology has not changed accounting profession yet, as you might agree. So one obstacle is the need of the technology to support the internal control environment, similar to the technology developed based on the ERP system we currently use. So that's why our paper proposed the blockchain-enabled continuous auditing with the integration of business process management technology, process mining technology, which has been part of both continuous auditing theoretically and practically. So, okay. So in our framework, blockchain business process management enables the monitoring and managing business operations, while process mining continuously evaluates the effectiveness and efficiency of business processes, and entities internal controls and update the business process model using real-time data. In addition, blockchain technology offers immutability, transparency, and trustless environment to support those two technologies, business process management and process mining, and altogether they comprise a continuous auditing tool that improves the ability to evaluate effectiveness of internal controls. This framework takes hybrid approach, as many other blockchain implementation and computer science literature do. So using the off-chain database and the rules, and then on-chain database and rules, which I'm gonna explain more in the later slides, we expect that this can gradually promote the blockchain adoptions and make auditors and managers more comfortable using the model. Also, we use the case study of the state of Santa Catarina in Brazil to demonstrate the technical feasibility of our model. So I'm expecting two contributions of our paper. One contribution is that we are proposing continuous auditing framework using the blockchain and process mining and business process management to achieve the continuous auditing. And another thing is that we demonstrate the technical feasibility using the real case study, which is procurement process of the state government. So since we say that we're taking a hybrid approach, so I find the necessity to define the degree of blockchain implementations, like the degree of it. So the minimum implementation is where the data is primarily stored in a traditional database, and then only the digest hash version of the data stored on blockchain. So the primary purpose of this implementation is to prevent any modifications, so that if there's any modification, they will change the hash value, and then it will be notified by other people. And then the hybrid approach is data still primarily store off-chain, but they store the real data, the data itself on the blockchain instead of the hash value, so that people can actually look at what the data is on blockchain. And then advanced hybrid approach also use the mainly off-chain database, but it facilitates smart contracts to for the automatic execution of the rules, and then store more portion of the data than the hybrid implementation. And the complete version is not currently available, but this is described in the Dr. Dice and Vasarely paper in 2017. But due to the cost, so which means that entirely use blockchains and then using smart contracts to for internal controls. And then, however, currently because of the cost and then limitation of blockchain, this is not feasible currently. I mean, it's technically feasible, but people were not willing to do it. But that's like a complete implementation that we're looking at. And then this is our framework. So we have off-chain and on-chain. So on the off-chain, there we have our user interface and then the relational database. And then using the data from the relational database, we extract the data business process model using process mining techniques, and then using the business process management software, we can execute some process automatically and then monitor the process and then optimize the process and automate the process also. And then we also have on-chain, which is a part of the data, and then rules will be executed and stored on using the smart contract on the blockchain. And then using those extracted business process model, we can actually create or refine the smart contract rules. And then since we are using Ethereum in our model, so the data and the rules stored on-chain will be visible to public. So external auditors or stakeholders, such as in our case, citizens, can monitor the overall process on-chain. And then internal auditors or managers can monitor using the business process management component. So as I say, we have user interface at the front, and then we have on-chain and off-chain components. So off-chain, all the rules are governed by the business process management components, and then those data are stored on off-chain database. And then smart contracts, those rules that needs to be on-chain, then we use the smart contracts, and then those data are stored on blockchain. So what to include on-chain and off-chain. So in order to give a guidance to the which to store on-chain and off-chain, we define some criteria. So if the data is relatively closer and smaller, and then it should be permanently stored, and then it should be prevented from manipulations, those data are stored on-chain. Whereas if the data is less closure, such as like daily logs, or something needs to be modifiable consistently, then that should be stored off-chain. And then some of the rules that must be protected from the privileged individuals. And then if it's related to the public interest, we decide to put on-chain. And then something.
You have 1 minute left.
Sure, thank you. If something is related to internal, we store off-chain. And then this is the process how we implement this model. And then we use the case study of state government of Santa Catarina in Brazil. And then we're focusing on the contracting and executing process of the public purchase cycle. So there's two objectives in this implementation. First one is to develop the prototype using the blockchain-enabled smart contract technology. And the second one is currently their process is mainly done manually, such as once every step they need to send the email manually to the supplier and etc. So they want to automate those processes. Also, at the same time, they want to monitor their operations. So those are the two main objectives of this implementation. And then these are the software that we use in our model. We use Caminda mainly, and then Ethereum, and then Solidity, and we use HE2 for relational database system. So these are the examples of our prototype. For example, when we create the contract, the content in the contract, we think that it should be stored on chain because it is crucial, and then it should be transparent to the public to prevent any corruption might happen. So we store this content on chain, and for example, when we send material requests to suppliers, it should be run on chain and off chain because those material requests is important, and then we want to know who made a request. So those information stored on chain, and then sending those requests should be run off chain because we want to automatically send an email to the supplier because that cannot be run on chain. So that's off chain activity. Those are the couple examples. And then this is the step that we focus from the purchasing cycles. And then you can see that after the process, we record the content of the contract on the blockchains. And then after, we also input the smart contract rules. And after 1 year, it automatically distributes the smart contract. Also, it terminate off chain and then send the automatic message saying that the contract is terminated. And then this is user interface. And later in the stage, we develop this one looking more prettier, but I include this one of the user interface. And then after we input the data, this is the data posted on blockchain. And then this is the examples of the email that automatically sent from the system to the supplier once the contract is terminated. Yeah, that's it. Thanks for listening.